These are practice questions dealing with regularity. In order to solve 4, you need the content that a third-year junior high school student would learn, but the content up to 3 can be understood even by a first-year junior high school student. The most important part is up to 3rd grade, so I think it would be great if students of all grades could solve it. The trick to solving regularity questions is to think about how the number of orders appears in the shape. The whole thing is lined up in a square shape, so if you don't care about the color, the panels will be lined up vertically and horizontally as many times as you like. For the second one, 2 times 2 is equal to 4 pieces. If it's the third one, you can see that there are 9 panels in 3 by 3. Would like to count the number of white and black pieces using the number of orders, but in this question, the counting method is different for even and odd number. For even numbers, you can count both white and black very easily. The same number of white and black colors are lined up in a horizontal row. Even if you consider the whole square, the number of white and black pieces is the same. For example, if it is number 4, the total number of sheets is 4 times 4, 16. Since there are half white and half black, you can divide it by 2 and calculate that each has 8 pieces. It seems that you can easily calculate any shape as long as it is an even number. In 1, you are asked the number of each of the 6 pieces, so the total is 36 pieces, divided by 2, and you get 18 pieces for each piece. In 2, the nth black number for the even number is expressed by the formula 1. In the even-numbered case, we know that the number of white and black sheets is the same, so using exactly the same idea, let's express it using an expression. The total number of pieces is n times n, and there are n squared. We divide this into half white and half black, so the number of both is n squared over 2. In 3, you are asked for the number of odd black pieces. If it was an even number, it would have been easy to count, so if you want to know the odd number, you can think about how many more pieces there are compared to the previous even number. If it is the third number, the number of vertical parts, horizontal part, and bottom right part has increased compared to the second number. If it is an odd number, the number of panels in the same location will increase compared to the even number 1 before it. The vertical part, the horizontal part, and the bottom right part. You should be able to calculate the number of these increased parts using numbers. The number of pieces in the vertical section increases by the number of pieces in front of you. If it is fifth, add 4 cards to the fourth one in front. The number of sheets on the side will also increase by 4. And the number of white and black pieces in these 2 parts is the same. It's always an even number, so it's half white and half black. If it was number 5, both white and black would have increased by 4. Also, the panel added at the bottom right is always black. This is because the top left panel that I started with was black. Now, let's think in terms of letters. N plus 1, the 1 before the th is the nth. From 2, we know that the nth black number is n squared over 2. Here, n in the vertical and horizontal parts, a piece of black is added. Furthermore, 1 black piece is added at the bottom right. So n plus 1, the number of black pieces, is n squared over 2 plus n plus 1. Even numbers and odd numbers occur alternately, so in questions like this one where even numbers and odd numbers are counted differently, you may think about which one is easier to count. Question 4 is for third-year junior high school students and uses a quadratic equation. The formula for expressing the number of blacks is different for even and odd numbers, so first let's consider whether 85 cards come in even or odd number. If it's an even number, it's n squared over 2. Since n is an even number, this formula can only represent even numbers. For odd numbers, n squared over 2 plus n is always an even number, so n squared over 2 plus n plus 1 represent odd numbers. Since 85 is an odd number, we know that the answer will be an odd number. Now, let's create an equation that shows the number of black pieces is exactly 85. Let's consider whether it is possible to solve a quadratic equation by factoring, and try to factorize 168 into prime factors. Let's consider dividing the prime factors into two factors. Since you have to be able to make 2 when you add them, you have to divide them into two numbers of the same size, so I want you to find a combination of 12 and 14. We know that n is 12, but what we need to answer is the odd number n plus 1, so we add 1 and the answer becomes 13.